All right, this is Josh and Nick back at Wisconsin Lighting Lab, and today we're going to be doing a little conversation about string lighting. Nick, what is string lighting?
So string lighting is generally the application is like a courtyard, or if you think like restaurant, like beer garden, um, patio area, and essentially it could be as little as just your Christmas lights, strands of that, or most cases when it's more the commercial side, it happens to be more commercial grade lighting, so bigger bulbs. As we kind of have in the document, you'll have like anywhere from 12 inch out to 24 inch separation with the bulbs, and they could be anywhere upwards of 8 to 10 inches in diameter. So, and then with that, there's usually a guide wire that they're tied into, and then you have to tie it into either, in most cases, a pole is what they're looking for, of course, and then sometimes the other end might be tied into a building. But essentially what we're looking at is how to size the pole for the application.
Yep. So, just to simplify that just a bit, you have one pole or multiple poles, and you have a string or a wire that goes between the poles, and off of that string you have lights hanging.
Yeah, correct.
And then there's numerous different applications and designs, but the simplest way to put it, that's kind of how it goes. I know traditionally poles are engineered to have the static load, so a light fixture or bracketry on the top of the pole, and they're not tailored to have the side loading that the strings, the tension that they pull.
Yeah, they're meant to be more freestanding, like I said, static load, light fixture, camera, banner, which we've discussed in previous episodes. But with string lighting, it's putting a constant horizontal load on the pole, where you'd only get that horizontal loading when the wind picks up and it hits whatever you're mounting to the pole, and that's what caused that. But you still get more of a, there's a reaction. Poles are meant to sway, and that's what you see is, the pole gives and it sways back, where with string lighting, there's no sway. It's a constant horizontal load, a lot of times in just one direction. If the pole's in the middle of the string lighting, then you have opposite forces, which does kind of help even it out. But at the same time, there's different forces that act just by having that loading like that.
Okay, yeah, and since it's kind of a non-standard type of application, it's a bit of a engineering nightmare.
Yeah.
So there's a lot of details that are needed for us to process. What specifically, if somebody has a string lighting job request, what do we need to know?
So the few ones are the size of the wire, because generally there's going to be a wire that's going to take the loading for the string lights themselves, because the string lights are usually just that. It's just copper wiring running to each bulb, and copper wire in of itself doesn't have a good isn't structurally sound to kind of support itself. So you have these guide wires. So first one is the size of the wire. From there, you kind of just work your way through the materials and the distances. So from there, you look at the sag, how much if you draw a horizontal line, how much in the center does it sag down, which essentially you're looking at the tension of the cabling at that point. From there, distance between the poles, which again, that kind of coincides with the sag and the tension between that. And then from there, the mounting height, how tall the pole will be, and then the clearance height, which kind of takes into account, the sag, and then the clearance, how high up you want the lights to be. Generally, you're probably looking at 8 to 10 feet. I think like a ceiling in most buildings, you're looking at 8 to 10 feet there. So if you have 2 foot of sag and you're looking for 10 foot of clearance, you're probably looking at about 13 to 14 foot pole, because you're not going to mount the eye bolt right at the top of the pole. You're going to be down a few inches there.
Okay, and I know we have a sheet that we put together for our customers to go through that outlines all the required information. So, we can provide that on the front end. So then our customers know what they need to provide us, along with the diagram. So that really helps. And I know we also require like a site plan, or a drawing of the site that shows the layouts of where all the poles are and the spacing. I know there's a few other jobs that we've done that the string lighting were on the top of a building.
Yep.
So obviously, where the poles are being mounted is also important to know.
Yeah, your loading changes a little bit different. Engineering criteria changes a little bit when you get up to, a building top. We look at it the same way. If you were putting poles on top of a parking structure for just general lighting, it's the same concept. The engineering changes a bit when you get up on a 4, 5, 10-story building. So you kind of have to take that into account as well.
Okay. And what if a customer doesn't have some of this information? What happens then?
We'll pretty much need all the information, but if there is something they're a little unsure of, one of the things we call out is the wind speed. That's something we could certainly help them with, because if it's just a general parking lot pole, we would look at that anyway. So if they're not sure what wind speed they're in as far as the part of the country, we would assist them with that. If there's any clarifying questions, obviously we built this document so we kind of know what we're looking for, but it might be some new project at the first time they've done it. So things like the bulb spacing, if the spec sheet doesn't really quite call it out or anything like that, we can look at that for them. The sag, the clearance height, if they're not sure on some of that information, we can make either recommendations or advise them on what we're looking for, what they need to follow up on.
Okay, but generally we need to have this sheet completed in full, so then we can take it to our engineers, because these types of jobs are probably the most engineering intensive jobs that we deal with.
Correct.
So we do require that information in order to move forward, and once we have all that information, it still can take a few weeks for engineering to do a review and then recommend an adequate pole to handle that loading.
Yep.
Okay. I know one thing too I want to touch on. Sometimes string lighting is also referred to as festoon lighting.
Yeah.
We hear a lot of that in the industry. I'm not sure exactly where that derives from. I think part of it is because sometimes string lighting, the lights from these applications will actually plug in to the top of the pole, so they'll have a GFI provision or a festoon provision installed in the top of the pole, so the lights can plug in and run power through there. So I think that might be where that kind of stems from, but I'm not sure. But otherwise, that's a common synonym for string lighting is festoon lighting. Okay, great. Is there anything else that you wanted to point out?
Going back to the site plan, one of the things we kind of touched on is multiple poles. Sometimes you'll have a pole that maybe in the center where there's there might be 4 string lights going to it. Stuff like that is what we're usually kind of looking for in the site plan, so that we know, where's the end of a line of poles, because the one on the end might have to be the strongest versus one in the middle, is being counteracted. So that's kind of mainly why we're looking for the site plan. It's not so much that, a lighting layout or things like that, just to get an idea as far as, what angles, do you have a bunch of right angles for the poles, or is it just one straight line? So that's kind of what we're looking for in the site plan side of things.
Okay. And one last thing, what material do you see most of the poles made from?
Generally, we try to focus on fiberglass. The main reason being the fiberglass poles are also used in utility lines, primarily down in the south, it seems, where a lot of our fiberglass poles go to begin with. So they kind of seem to already have the engineering criteria behind it. When you think utility lines, a string line application is just a scaled down version of utility lines, essentially. And for that reason, when we talk about right angles or, end of a line, if you look at a utility, utility poles, if there's a pole at the end of a line, there's usually a cable that goes down to the ground that's anchored, and then some people think it's to ground the pole. Well, it's actually, counteracting the pull, the tension of the wire going the opposite way. So since most people don't have the ability or the room to have a cable that's kind of offsetting that tension, that's why you have to engineer the poles a bit more robust so that they can hold themselves up without having guy wire going the opposite direction kind of holding it up there. So fiberglass is the most common. We have done them in steel in shorter poles and in shorter spans. Aluminum is pretty much a no-go, although a lot of people tend to call out aluminum, and I think it's partially because they think string lighting, a 15, 20, 30-foot run of lights, they pick it up, it's like, oh, this weighs maybe 5, 6, 7 pounds. What they're not realizing is the tension that's the issue there, and aluminum just structurally isn't sound for it. So fiberglass is what we focus on the most. You don't have a rust factor to deal with. They're pretty much self-sustained at that point. We have done it in steel in many cases too.
Okay, great. I think that wraps up everything that we wanted to touch base with for string lighting applications and requirements. Stay tuned for our next Willcast.